answers we've been getting, and you're going to come up with the question. So the answer is dy dx equal, and don't call it out, okay? You can write the answer down, but don't call out the answer. I'm going to ask you with the inspire. Okay, so there's the answer, and you're going to need to come up with a question. Oops, I'm sorry. You don't want that question again. Okay, so the question would be, what is the derivative of, okay, you have to, pardon? I will. Okay, so let's get that here, and there is the, oh, well, that doesn't help us much, does it? Okay, well, we'll stop it. Okay, we'll start it again. Now see what you have there. Is that working better? Okay. Okay, don't give your answers away. You might get a prize. The ultimate prize in this class is understanding. Understand.
Are we finding the derivative of that?
No, wait a minute. Keep in mind what we're doing here. Jeopardy gives you the answers, right? And I'm saying the question you would call, you know, like in Jeopardy. Hang on. Don't you know how to play Jeopardy?
Is it okay if you put?
That's okay. You can just give me the blah blah blah. Okay. I'm okay with that. Again, this is just like Jeopardy. I give you the answer. You come up with the question. Frank, would you roll those screens so that they are, I'll tell you if they're wrong, I guess. Just close them one way, and if they're wrong, I'll tell you to go the other way. Yeah, go the other way. Oh, no, you're fine. You're fine. That's good. And then do the one behind you. Can you reach that? No. Okay. Thank you, Frank. The sun blends. It's both would have sun. Blends on those bars over there. Thank you. Thank you. Okay. I took him away from his inspire. Did you have it answered already? Okay. 2 more people. Now, how many of you have had calculus before? Did you learn a rule? Did you go over this? You learned a rule? That's great. Don't forget the rule, but I want to know why the rule you memorized works. The rest of you, if you've never seen this before, I'm curious in your thought process. How did you go about determining? And once you thought you had the answer, did you check it? And what would you have done to check it? Don't answer out loud, but that's what I'm going for. Okay, one more person, and then we're going to see what kind of answers you have. Okay, so let's see what we've got here. There we go. X squared plus 3x. A lot of you gave me that answer. Are you sure? How would you know you were sure? You were correct. Take the derivative. Yeah. Take the derivative of x squared, you get 2x. Okay. Take the derivative of 3x, you get 3. So I would say yes, that answer is correct. This one's just as correct. This one, I think the person meant to put it the way the others are, but they didn't get the exponent in there, so we'll accept that as true. Actually, I only see one truly correct answer. Let's see, guys. I'm not sure what this little thing is down there. It doesn't seem to want to go down there. Okay, someone's got something down there, but it's not showing it. There's only one really correct answer. All of you got most of it right, but let me ask you. Suppose that I said your answer is not completely correct. It instead is x squared plus 3x minus 4. Who's correct, you or me?
We wouldn't know that because minus or so we take 0.
Absolutely, but I'm right. Okay? So when we don't know for sure what it is, it's being indefinite. And the way that we express that it is indefinite, that there's more than one possible answer here, is to put down that there is some constant. And the person who gave that knew that, I'm assuming, from another calculus class. X squared plus 3x plus c. Because that c says there's many, in fact, how many different functions could we have that had the same derivative? Yeah, infinitely many. Okay? All varying by that constant term. Okay. Well, you guys are doing well. Let's see what you do with the next one. Okay. And let me get this set up so that it appears it's taking you just a little bit longer. Okay? Let me help you out. I'm not going to tell you the answer. It would not be fair to you, because you want to have the joy of finding it yourself. But let's think about what are the steps to taking the derivative. The first thing, we'll just take this term right here. The first thing we do is, how do you take the derivative of x squared? Well, when you bring it to the front, it's because you are, and someone over here said it, you multiply the exponent to the coefficient. Bring to the front is not really a mathematical term. Okay, but what we're doing really is multiplying, right? Yeah. Okay. It's like over is not a mathematical term. Okay, here we go. Once we do that, what's the second thing? It's only 2 steps. What's the second thing? And when we decrease, we're actually doing what? Subtract 1. Now you'll see why I'm being specific on these mathematical terms. We subtract 1 from the exponent. Now, when you did this one, a lot of you got this done pretty fast. When you did this one, think about the relationship between 2x and x squared. Going this direction isn't too bad. We've been doing that all semester. Going in the other direction is like finding an inverse function. And again, I have to be careful saying that because we're not, an inverse function is where we try to solve for the unknown. Well, that's not really what I'm doing here. But what I am doing is giving you the answer and having you go back to the question, the function. So, does that help you with this one? Because if you're going to reverse, turn around and go back, will you do the same steps? Did we do the same steps? And if you reverse, go backwards, the steps have to change? Okay. Give just a few more seconds, see if we can get just a few more people to chime in. Okay, I'm going to pause the poll just for a moment. Let's do a little more talking about this. So if when I take the derivative, I have these steps. When I go in the opposite direction, did you hear what I said? Go in the opposite direction. What does that tell you about the order of the steps? Yeah, Aaron? Yeah, we're going to have to reverse the order of the operations. And did you have another piece in there? And? Okay, and use the opposite operation. Okay? Now, think about that. I'm going to start the poll again to see how many others I can pick up now. Reverse the order of the operations and use the opposite operations. Okay, got a few more people who have chimed in. Okay, I'm going to pause it one more time. Let's see if we can get a few more of you. If I'm going to go in the opposite, reverse the order of operations, step 1 now becomes step 2, thank you. We're thinking backwards. And step 2 now becomes step 1. And if I use the opposite operation, instead of subtracting, I'm going to add, and instead of multiplying, I'm going to divide. Now, those of you who already have an answer, think about it. Did you do this? Maybe you didn't. Maybe you did and didn't realize it. So now let's see if we can pick up the other 10 people here. And if you haven't done already submitted an answer, go back and think. Wait a minute. Is that truly what it was? And walk through. Added a couple more words there. We would add 1 to the exponent instead of subtracting from it. I would divide the exponent. Whoops. I can't say that. Divide the. Now I got to say this. I got to divide the coefficient. I got to even change this. I should have read this first. Divide the coefficient by the new exponent. Okay, so let me start this again. Let's see if we can get the other 10 people.